Welcome to Math 104, Chapter 3.1, where we talk about quadratic functions and their parabolas. So, just like equations of lines, quadratics also have a few different forms. So, their general form is y equals ax squared plus bx plus c, where these values do a number of different things. This a here is considered your quadratic term. It makes it so that we're now dealing with quadratics because attached to it is your x squared. Now this one does something really cool. Because it is attached to your highest degree, this is considered your leading coefficient, which determines the direction. Your direction is either going up or going down, concave up or concave down. Now, b is considered your linear term. It's called your linear term because if a is 0, then that zeroes out this term right here. So then you're in the form of bx plus c, also known as mx plus b. So that is why your linear term is in the middle. It does not provide us too much information right from the bat. However, the last term here, c, is considered your constant. Keep in mind, a constant is does not have a variable attached to it, so it does not move based on what your x value is doing. This is also called your y-intercept. So 0, c is your y-intercept, and it is always only found in general form like this. So that's your general form. We also have your intercept form here. Your intercept form is equal to a times x, let's say plus p times x minus or plus q, where p and q are considered your x-intercepts. And these can be either positive or negative. It doesn't quite matter. We're just going to be plugging them in and evaluating. And this a is actually the same exact a found in your general form right here. Those are equivalent. These are the exact same values. Now there is one more form that is not listed on here, and it is called your vertex form. This is also called standard form. This has y equals a x minus h squared plus k, where again, these a's are all matching. You have a here, here, and here, which all mean and do the exact same things. The difference between this one is now that it is going to give us your vertex. Now, if you don't know what a vertex is, that is going to come in just a moment. So h and k are the vertex of the graph. And this is a point h, comma, k. Now notice h, when we plug it in, has undergone a sign change, very much like what we've done over here. Whatever your x-intercepts are, we then do a sign change. So if I were to show that again over here, let's say we say minus, minus, we would have the point p comma 0 and q comma 0. It does not mean that p and q are only positive. It just means that they will be undergoing a sign change. So if p is negative, it'll be represented as positive. Same with q. If the q is negative, it will now be positive. Just into these forms. Now, how do we know if a graph is a quadratic is a quadratic? It is a function, a quadratic function without graphing it. right? So the key identifier is that you have this squared term here or multiple x intercepts. Multiple meaning just two x-intercepts. So big takeaway, if you spot a degree of 2, which is the highest degree. Now let's take a look at your graph. Like what would we be seeing? Well, on the anatomy of a parabola, we have some sort of a parabola here. And we are going to create just a general graph right here. Looks good. So this is our graph of a parabola. Now, can you identify key features on here just by circling and labeling what they would be? Well, these would be your x-intercepts. So these are your x-intercepts. This is what you could call your P and your Q. Your y-intercept would be located right here. Your y-intercept in the form 0, c if you're using from the above. Now you also have something called a vertex. Anybody know where it is? Your vertex, if your graph is nice and symmetric, it splits your graph up on either half. It is the exact same, which happens to be called your axis of symmetry. Now this graph is going up. We could certainly have one that is flipped upside down, but the axis of symmetry really just separates your graph into two equal parts. Now these equal parts will also contain your vertex. Your vertex being right here, your vertex contains HK. Now your vertex and your axis of symmetry do have an equal value, this being your H value. Now this is just a way to separate out that, hey, this is a unique value. This is really, yes, these are just X's and Y's, but this one is a unique X and Y. It is the lowest or the highest point of your graph. So if we're looking for the axis of symmetry, this has the equation X is equal to negative B over 2A. So as long as you have this particular point or this particular value, we can also plug it into your formula to find your Y value. So it can also be written as negative B over 2A, comma, F of negative B over 2A. That just says, hey, we can plug it back into your original formula to get out the vertex. Your vertex being either your highest or your lowest part of your graph. Now, last thing we're going to talk about is the concavity. We mentioned it a little bit earlier about A determining the direction. So now we want to know, how do we know if it's going to be the upward one or the downward one? So if A is greater than 0, so that means if A is positive, that means we have a graph that is going up. It is called concave up. Think about being able to spell the word up, which will now give you a minimum, the smallest part of your graph. Whereas if it's negative, so A is less than 0, so A is negative, we are now concave down. Oops. Now to memorize this one, think about spelling the word down, D-O-W, and that can be your N of the down. And this one will have a maximum. So it's all about A. If A is positive, your graph is going up. If A is negative, your graph is going down. Think about all the power that the leading coefficient has for determining the direction. So now let's graph a few of these and determine the concavity, the max and min, and find some of these important features of your graph. So we have y equals x squared plus 8x plus 9. Okay. So here we have a graph, and we are determining the following concavity. Well, first off, is this a good graph? Well, this might be considered an okay graph, but notice we are missing the lowest part of your graph. So we're going to change it, your y, to go a little bit lower. So let's change it to maybe -15. I'm going to get pretty low to get a nice looking graph. I also don't like how there's so much empty space to the right side. So I might not need to go to 10, but maybe to 5. There you go. So that is a much better looking graph. However, I did in the process though of cut off an important feature, or maybe we didn't even have this important feature. But we'll come to that in a moment. So do we have a concave up or a concave down graph? This one is considered up. We are going to be increasing, and that comes from your A. A is what number in your equation? A is directly attached to the x squared, so if we don't see it, it's going to be 1. So your A is 1, so it's giving us that nice rounded U shape. Now let's take a look at your vertex. Where is your vertex located? So your vertex is located right here at -4, -7. Now let's take a look at your x-intercepts. We have here at -1.354 and another one at -6.647. Now, do we have a y-intercept? So while I can't see it on here, I can also pull it out from my equation. Your equation, your y-intercept is going to be that 9 found out in front, or sorry, out in the back. Now we can also adjust your graph to make that accommodation. We need to get a little bit higher than 6.8 something something. So perhaps knowing that it's 9, maybe we go all the way up to 15. And then we can clearly see that your graph hits at 0, 9. So this is what we can do graphically. So over here, concavity, let's answer a few of these. Concavity, we said it was up because A is greater than 0, A is equal to 1. So it's positive, it's going to have that up feature. So are we going to be a max or a min? A is going to be a minimum. We also said your vertex is going to be at -4, -7. Your y-intercept, we said, was 0, 9. And your x-intercepts, I did not actually end up recording them. We can always certainly go back. Now, we don't know how to find them algebraically quite yet, so I actually might scratch that out. But more likely, I'm just going to say for now, C graph. Last one is intercept form, which we will talk about in a moment. So let's say we wanted to do some of these features algebraically. The first one, concavity, other than graphing it, we can determine your shape of the graph given your A. We said A is 1 from here. So that being said, we can determine that it will have this U shape, which then will lead us to a minimum. But let's figure out how we can do your vertex using algebra. Well, that is going to come into play with the axis of symmetry. Oops. Your axis of symmetry has the equation x is equal to negative b over 2a. Now, where are those b's and a's coming from? Well, we already determined what a is, so that just means we need b being 8. So we can sub in those values. We have negative 8 over 2 times 1. So negative 8 divided by 2 is negative 4. So this is the negative 4 that you're seeing here, which now means we need to figure out, well, how did we get this negative 7? We said, hey, if this is your x value, if we have negative 4, we're going to plug it back into the equation to then find your y. So let's go ahead and plug this back into the equation. So we have y is equal to negative 4 squared, put it in parentheses, plus 8 times negative 4 plus 9. So we have 16 minus 32 plus 9, which does come out to negative 7. Now for your y-intercept, this is just coming from C. C is 9, which is your y-intercept. Now your x-intercept, we don't know how to calculate quite yet, other than looking at it on your graph. So we can also put down here that we will be learning how to factor. Now, if you already know how to factor, you can certainly try to factor this out. But if it doesn't work, that is okay. That is what our next lecture is going to be on. Now, intercept form. Intercept form, actually, sorry, it wasn't supposed to be intercept form. This is supposed to be vertex form. Your vertex form is y is equal to a x minus h squared plus k. Now your a is the exact same a as the one before it. So a, we already said, is equal to 1. That is all the way from right here. So we can go ahead and plug in that 1 right there. X is just x, we have the square, and now we need to determine hk. Your hk is actually coming from your vertex. Your vertex, we said, was negative 4, comma, negative 7. This being your h, this being your k, and we're going to sub that right in. We have negative 4 plus a negative 7. So then we're going to fix it up and make it look nice. We have y equals 1, x plus 4. Notice that there's a sign change, minus 7. Now, if we were to plug this into your equation over here, or your graph, we have y equals, a is 1. We said x plus 4 squared minus 7. And notice we went from a red graph or right onto the blue graph, which means they are the exact same equation. Now, whether you want to do it algebraically or on your graphing calculator, it doesn't matter which one you choose, but let's try to have you guys pause the video and come up with the next form. This one, just try with vertex form, and if we have nice intercepts from your graph, then we can work on intercept form as well. So if this is your graph, let's see, 2, 3. This one, it does says to have a viewing window that is specified. So it's negative 10 by 10 for both. So let's go ahead and make that change. Well, this is actually a pretty decent looking graph. I do want to make sure we have some practice with specific windows. Okay. So here you have your graph on a 10 by 10. Now let's go ahead and find all of your special features. So we have your intercept, your y-intercept, and are we going to be having x-intercepts. No, we're not going to be having x-intercepts. There's no way that we can get your graph to touch the x-axis. So those are the features I think we're only able to find. So concavity. Well, your concavity, we said, is looking like this. So we are concave down. This also comes into play because A is less than 0. So A being -1 is less than 0. So it will be concave down, which will give us a maximum. Your vertex, we said, was at 1, -2. That also can be found by plugging in some of your values into the equation. So if we tried it with your equation, -b over 2a, we could also say this is -2 over 2 times -1, which is your +1, which we can go ahead and plug right back into your equation, which will spit out a -2. Now you have your y-intercept, which is coming directly from C. And your x-intercept, we had none. Now, when it says intercept form, we really want vertex form. So y equals a x minus h squared plus k. So the two features we need is a and your vertex, 1, -2. We said your -1 is your a. So let's go ahead and try fitting that in. A is now -1. X minus your h, keep in mind this is just hk, squared plus a -2. And there you have your vertex form. Let's see what we have up next. So now a more applied problem. It says graph y equals 0.01 x squared plus 12x on a graphing calculator on this particular window. Is the graph concave up? Does this window give a complete graph? If not, adjust the window to see the vertex and the x-intercept. Is the vertex a max or a min? And then give the coordinate. So I'm going to do this one on the TI-84. So I'm going to have to, okay. Okay, so we have 0.01 x squared, and I want to say it was like plus 12. Let me just verify one more time. Okay, we're going to do just a standard viewing window. There we go. Let's graph it. Now, is this a good graph? No, it is not very good. We are not seeing our important features. So one thing though, as long as we do see our graph, that is nice. We might want to consider looking at some of your values. We go from your linear term, your quadratic term, and typically you have your y-intercept, your y-intercept, which in our case is 0. So assuming though, are we going to be a concave up or a concave down graph? Most likely a concave up. So let's go ahead and adjust your window. Your x values, we definitely want to see more of it. So maybe we expand a little bit further out. And we definitely want to get up and maybe down a little bit more. So let's go a little bit heftier. Let's say 50 and 50, as long as they didn't tell us another window to do. Let's change your x scales to 2s, maybe 5s. Let's take a look. Still not great. So let's try that again. One. Oh, this thing is huge. Oh, come on, graph. Don't be like that. Oh, this app has been more and more frustrating over the years. Oh, that's not even going to do it. tell us another window? No. Oh, did I enter it in correctly? That could also be a huge factor. Yeah, no, that's good. Let's get a little bit bigger. Oh, you're right. That's probably what it is. Oh my goodness. Oh, this calculator is so frustrating. All right, I'm not using that calculator today. All right, let's try it again. I think it's because your y values are going to be small. 0.01 x squared. There we go. That's why. Plus 12x. It is plus, okay. They said on a 10 by 10, which we are. And so let's expand outwards. We can hit this button right here. I wonder if I did make a mistake. Yeah. So notice that we were seeing here, we definitely want to expand out a little bit more. So you'll see that nice curve. So when in doubt, just keep like breaking it up. It would have been okay had my graph been working a little bit better and not give me such a hard time. So that is one thing about your apps. Not always the best apps. For those that are taking it online, I would suggest Desmos at times to do more graphing stuff. We will be flipping onto your apps more towards the later half. But those that are in class, definitely keep your physical ones on hand. So from here, we can determine the following. We were looking at your intercepts, I believe, and your vertex. Okay, so up or down, we can determine that it is concave up, which means we have a minimum. Your vertex, we just saw, was negative 600 and negative 36. Good. Give the coordinate of the vertex. Oh, we just actually did that. That I'll just put over here. Minimum right here. If not, adjust the window. Oh, okay, that's actually all I wanted to ask for. So our window at the end was something like this. So notice that it's a pretty big margin. So again, if you're just, I think initially we're somewhere in here. So it's great if you can see the graph. If you're having a hard time getting started with your graph, definitely identify where your y-intercept is and then slowly start to expand. Get an idea of what it looks like in your head, and then we'll eventually get to see the complete picture. All right, one of our last examples, it says a ball is thrown upward at 20 meters per second from the top of an 80-foot building. The height of the ball is given by the function. What is the max height of the ball? Find the t and the s coordinate and find all of those features. Now this one, I'm going to attempt one more time on this graphing calculator. It's just been giving me a few hiccups. All right, negative 49. Okay, one more time. Let's try and reset. Okay. All right, so negative 4.9 squared. Okay, so something like this. I do not believe it gave us a viewing window. So that means it is up to us. So if I go ahead and hit graph, it might show a little bit of it, which is great. But keep in mind, what is your y-intercept? Your y-intercept being 80. So we want to adjust and accommodate for us. So notice that your y max is set at 10. We want to get above an 80. So let's do well above 80, which is maybe 120. And we can always adjust from there. And actually, that's a nice looking curve. So we can see your y-intercept, both x-intercepts, and the height of your graph. So let's go ahead and find your vertex by hitting second trace, and all the way down, we now have to determine, was it a max or a min? Well, with it being concave down, we have a maximum. So it says left bound. It just means get to the left of your max, which I'm now at the left. Let's do it to the right. Go ahead and hit enter. And then there you have your maximum height, 2.4 and 100.4. And so sorry, I think I said 2.4. This is really 2.04. Meaning in the context of your problem though, what is T? What is S? T is seconds and S is your height. So then over what interval is the ball increasing? Well, if our graph looks something like this, when we are increasing, oh, actually, let me redraw that. Oh, one last time. When we're talking about increasing, we're talking about the height is increasing, which means negative time doesn't count. We're going to be looking at this value over here. I believe is that what it wants. Yeah. So let's take a look at where your graph starts at 0 time, which our 0 time is really represented by your y-axis meeting your graph. So where or what coordinate is right here? Well, this is really your y-intercept where we know it is 80. So starting at 80 and going all the way up to what value is the ball increasing? Well, your interval of increasing is going from, and I should say it's not so much over your height, it's actually over your time value. So we're going to be going from 0 all the way, actually, from 0 all the way to 2.04 seconds. And notice how we're not going to be including this value because before we actually launch this ball, we are actually stationary. We haven't moved, we're not increasing, nor are we decreasing, but the second we do, it's gonna get as close to the start as we can. And then at the height of your ball, well, at the height, we've kind of stalled out. We're not moving, so we're neither rising nor we're falling. So then we stop. Now, when does the ball fall to the ground? We wanna figure out what is your x-intercept. Now notice here we have 2x-intercept. This being negative time, which we do not need, right? Negative time is not possible. We cannot go back in time. So anything that's here in red, we're going to discount. So that just means what we do want to identify is this value here. So let's go ahead and figure out how long it took the ball to fall to the ground. Now, as long as we see your x-intercept, which we do, we can hit second trace and go all the way down to 0. When we do that, it's asking for left bound. It just says get to the left of your x-intercept, which we are. And then one more time to the right. And then here you have your x-intercept at 6.57 or so. It's actually not x, our variable is t. So it'll take 6.57 seconds to fall to the ground. Now let's try this one more time with our last example. It just says the profit for a profit for a product can be described with the following equation. So where X is the number of units produced and sold. To maximize profit, how many units must be produced and sold? What is the max profit? Now let's do this one in Desmos. Let's see, 100. Oops, that's not it. I hit it again, didn't I? Okay, let's reset. We have y equals, and I already forgot my number. Okay, so that is our equation. If we were to rewrite it where you can actually have your have it in descended order, we certainly could by mixing and arranging, but notice that your graph is not found off on your page. So instead, keep in mind, if that happens, let's take a look at your y-intercept. Your y-intercept is super, super negative. So let's at least figure that part out. So let's try your graph. And because it's super negative, we want to get even lower. So let's say, let's do 3,000 to be safe. Notice that we can now see it. Let's get a lot higher as well. Let's say maybe 6,000. That might be a little much. Your time, that might be okay with -10. Oh, let's keep -10 for now. I do want to get maybe further off to the right, which means let's try 50 out. Ooh, so notice that I am seeing a nice curve. I do see that leveling off, and I might consider as well changing my how much I go up by. So 3,000 and 6,000, maybe I go up by 500. Your axes, I definitely want to get further to the right. So let's try it out as 100. Ooh, that's a good looking graph right there. I won't mess around with that one, but maybe I have too much here. So let's dial it down. There we go. So there is our graph. Now it does ask us at what point are we going to achieve your max profit? That is just saying, what is your vertex? What is the maximum? So we have 50 and 1,000. And let's put that in the page. We said 50 and 1,000. So let's put this in a context. So what does the 50 actually mean? What does 1,000 actually mean? Well, if X is the number of units sold, Y is equal to what? Or P of X is equal to what? Profit. So how can we bring this together in terms of the context? Well, something along the lines of it will take 50 units sold to achieve a max profit of $1,000. And that's all you need. Now, if you are asked in the future and you have something that says revenue and cost functions and to create a profit function, it's actually pretty straightforward. This just says your profit function is equal to your revenue function minus the cost function. So whatever you have for your cost, we're just going to subtract it away from how much you make, and there you would have your profit.